Hello friends, in this video we will discuss the chapter Polynomials. This chapter will be discussed in the following 4 segments. First, introduction, in which we will discuss degree of polynomials and zero of a polynomial. After that, geometric meaning of zero of a polynomial. Then, relationship between zero and coefficients of a polynomial. And finally, division algorithm for polynomials. Let's start with introduction. Before discussing much more about polynomials, we need to know some terminology or terms related to polynomials like constants, variables, terms, coefficients, degree, leading term and leading coefficients. Let's start with constants. You already know any fixed value, okay, any fixed value like -1, 2, 5, 6, etc. These are constant. Variables x, y, z, these are variables, means the value of this x, y and z keep on changing from problem to problem. Next is terms. Let's look at an example. Say you have 3x plus 5. Okay, so 3x is a term while 5 is another term of this entire polynomial. Similarly, you have 3x square plus 2x plus 3. So 3x square is one term, 2x is another term, 3 is another term. So 1, 2 and 3, this polynomial has 3 terms. Similarly, say you have only a constant value, so this is a single term, and you can see here that this has only one term, this has 3 terms, this has 2 terms. So based on the number of terms present in a polynomial, these are given a specific name. For single term it is monomial, and if it has 2 terms then it is called binomial. Okay, and if a polynomial has 3 terms then called trinomial. Next is coefficients. Say for example you have 5x. So here you already know x is variable, 5 is constant. So when a constant is multiplied with any variable, then that constant will be called coefficient of the given variable. So here 5 is coefficient of x. Similarly, if you have 7y, then 7 is constant and y is variable, so 7 is being multiplied with y, so this constant term will be called coefficient of y. Similarly, you have 8x square. Here variable is x square and constant is 8, which is being multiplied here, so this 8 will be coefficient of x square. Next is degree. If any polynomial may contain at least one term or more than one term. Say for example 3y plus 7. So here variable is y, so the exponent or the power of variable is basically degree. Power of variables. Okay, so power of variables. Similarly, if you take example 3x square plus 5, what you find here, the variable is having power of 2. So degree will be of this term will be 2. But for this constant, you don't have any variable here, but we can write like this x to the power 0, because you know when a number given raised to power 0, this result out to be 1. So this constant 5 have degree of 0. So remember from right now that any constant term will always have degree 0. Similarly, if I take another example, say 2r square plus 2r square plus 2r plus 6. So here variable is r, but this term, in this term the power of r is 2, in this term the power of r is 1, and since this 6 is constant, so constant have variables with 0 power. Okay, so degree of this term will be 2, and degree for this 2r term will be 1, and degree for this constant term will be 0. Next is leading term. You already know what is term. This time we will learn leading term. For example, you have 2x square plus 5x plus 3. So basically here the degree of this term is 2, here degree will be 1, here degree is 0. So which term of this polynomial is having highest degree? Obviously this term is having highest degree. That's why this term will be called leading term. Means the terms whose variable is having highest degree, that term will be called leading term. Similarly, leading coefficient. For leading coefficient, you know what is coefficient. So this time you want to know leading coefficient. So basically if I take this same example here, 2x square plus 5x plus 3, we will find that the degree of this is 2, degree of this one term is 1, but degree for this term is 0. So highest degree is of this term, so this term is leading term, and the coefficient multiplied with this variable is 2. Okay, so this is the leading coefficient. Next is degree of a polynomial. The highest power, which must be a whole number of variables in a polynomial. Let's take an example. X square minus 8x plus 15. So it is saying about highest power, and that power must be a whole number. So can you now tell me, here variable is what? Obviously the variable is x, but the power of this x square is 2. Here power is 1 because x is raised to power 1. 15 is constant, so power is 0. So highest power of variables in a polynomial. So this x square minus 8x plus 15 is a polynomial. What is the highest power here? Obviously the power is 2 highest here. So what will be its degree? Degree will be 2. Take another example. X cubed minus 7x plus 6. Here degree of this, you need not to write every times the degree of each term. Directly you can compare that. Here the power of x, since x is a variable, so power of x is 3, here power of x is 1, here power of x is 0. So obviously this 3 is the highest power of x, so degree will be our 3. Similarly, if you have another example, say 7y to the power 9 plus 6y to the power 4 plus 8y to the power 13 plus 5. So this time the polynomial is having variable y, but here you find that the highest power is 9, but here the variable is not the highest power. You can say the power of y here is, in this term, is 9, while for the second term the power is 4. For the third term the variable y has power 13, and constant, you always know the power of the variable is 0. So which one is the highest power? This 13 is the highest power. So what will be its degree? Degree will be 13. So let's take a very small example, say 3. So what will be its degree? As you know, this is a constant term, and a constant term can you can always multiply it with a variable with raised to power 0. So what is the power here of variable? This is the 0 is the power. Since this is a single term, so highest power will be also 0. So here degree is 0. So remember, degree of a constant polynomial always 0. Based on degree of a polynomial can be classified in these 4 categories as per your syllabus. First will be constant polynomial, second type may be linear polynomial, third type may be quadratic polynomial, and fourth type may be cubic polynomial. Since basically these are included in your syllabus, that's why I am discussing only this much. Let's start with constant polynomial. Any constant term like 3, 5, minus 2, half, 3/4, these are constant polynomial because these are, as you can see, the name is constant. In the name itself the constant word is there. So since these are the constants, so they are called constant polynomial. And you can see here the degree is 0, as I have already told you that any constant value can be multiplied with a variable raised to the power 0. Like say if you have 5, then you can multiply with x, but you need to put here power 0. Then only you can say that this 5 is constant. So here you are finding degree is 0. So always remember, a constant term or a constant polynomial always have degree 0. Now here I have written a 0 polynomial. So basically 0 is itself a constant polynomial, but given a specific name 0 polynomial. So you need not to think much more about this type of polynomial, and also not about 0 polynomial. When you find 0, of course this is a constant polynomial, but it has given a particular name, specific name, that's why we call it 0 polynomial. Next is linear polynomial. Any linear polynomial will be found in this standard form ax plus b, where a can't be 0 and a and b may be any constant value, but a can't be 0. For example, if I have an example like 9x plus 7, if you compare this 9x plus 7 to this ax plus b, what you find here that a is equal to 9 and b is equal to 7. Another example, say 11u plus 13. Then don't confuse that here is x is written and here x is indicating, basically you can write any variable here. There may be y, z, any variable. So in this polynomial you have u variable, so you don't confuse. If you compare with this, you will find that a is basically 11 and x is, which is a variable, which is a general form, so x is here written like u and b is equal to 13. Let's take another example also. Say you have 9r plus 5. Again a, if you compare this with the standard form ax plus b, you find that a is 9 and b is equal to 5, and I will not write here x, as I have written here x is equal to u. So you need not to write here x is equal to r, because here I have written for making understanding, to make you understand. So you need not to write here, only you need to write a is equal to 9 and b is equal to 5. Next is one thing that I want to tell you. Focus on the degree of each example that we have taken. You find that here the degree of this polynomial is 1. Degree is 1. Why 1? Because the variable is x and highest power of x is 1, so degree is also 1. Similarly for here, degree is 1 because here the variable is u and the highest power of u is 1. Similarly here degree is 1. So remember always that a linear polynomial will always have degree 1. Remember. Next, quadratic polynomial. Again, a quadratic polynomial will look like this: ax plus bx plus c, where a can't be 0. Why I am writing a can't be 0 here? Here also I have written a can't be 0 because when you put a is equal to 0, you will find that this ax term will vanish out. So when this term will vanish out, it won't be anymore linear, it will become a constant polynomial. Similarly, if you put here a is equal to 0, then x square term will vanish out and it will not remain any quadratic form, it will become a linear form. So this is the standard form. Take an example, say x square minus 8x plus 15. Since the degree of this polynomial is 2. Why 2? Because the highest power of the variable is 2. So degree is 2. Similarly, if you take another example, r square minus 9r plus 14. Again, the degree of this polynomial is 2. Because the highest power of the variable r is, for this polynomial, is 2. So what you are getting, that a quadratic polynomial will always have a degree 2, always have a degree of 2 for a quadratic. So that's why in the starting I told you, based on that, the degree of a polynomial can be classified like constant polynomial, linear polynomial, quadratic polynomial and cubic polynomial. Moving next to cubic polynomial, looks like ax cube plus bx square plus cx plus d, where a can't be 0. Similarly, the reason for not putting a is equal to 0 is that if you put a is equal to 0, then this x cube term will vanish out, because when you multiply a number with 0, after multiplication you get the product 0. So then it will not be any more cubic polynomial. Let's look at an example. Say y cube minus 11y square plus 6y minus 6. Here the polynomial is having variable y, and the highest power, if you try to find in the entire polynomial, you will find that here the power is 3, here power is 2, here power is 1 and here power is 0. So here power is 0, means you can write like this 0. So highest power is obviously 3, so degree will be 3. Let's take another example. Say you have 14y square plus 13y plus 6 plus 9y cube. So here you find that this term 14y square having the degree 2 for variable y. Here 13y term, the power of y is 1. Here 6 is constant, so power will be 0. And here in this term y is power having 3. So remember that it's not like that you will always get the power in like this arranged form, means like 3 2 1 0. It may be written in any random way. Then you have to it's your duty to look where which term is having highest power of the variable. So here you find that this last term is having power 3 to the variable y. So our degree is for this polynomial will be 3. So what we found here, we find here that degree of a cubic polynomial is always 3. So in nutshell, I just want to say that a constant polynomial will always have degree 0. Similarly, a linear polynomial will always have a degree, sorry, let me rectify, its degree. Okay, so linear polynomial will always have a degree 1, and quadratic polynomial always have a degree 2, and cubic polynomial always have a degree 3. Next is 0 of a polynomial. So a real number k is said to be a 0 of a polynomial px if p of k is equal to 0. Basically this px is the way of denoting a polynomial. Similarly pk is the way of denoting a polynomial. Similarly you can write qr or qx. This is the way of writing a polynomial. Let's take an example. Say you have a polynomial px, x square minus 8x plus 15 at x is equal to 2. You want to know what will be the value of this polynomial px. So what you will do, just substitute the value of x with x is equal to 2. So you will just, since this is x here, you need to substitute it with this value. So you have, that's why you have written p of 2 is equal to 2 square minus 8 into 2 plus 15. Just I am substituting the value of x and nothing else. You will get 4 minus 16 plus, so what you are getting, p of 2 is equal to 3. Since p of 2 is not equal to 0, so you can't say 2 is 0 of polynomial px. Let's take x is equal to 3 this time. So what will be here, p of 3 is equal to 3 square minus 8 into 3 plus 15. Just substitute the value of x here in the given polynomial. You will get 9 minus 24 plus 15. This comes out to be 0. This time p of 3 is equal to 0, means this 3 is k, which is a real number. When you are substituting this 3 in the given polynomial, the entire expression is becoming 0. So this 3 is 0 of polynomial px. There is a task for you to check whether 5 is 0 of polynomial px or not. This is your task to check. Next, Example, I will take from cubic equation. Say you have y cube minus 6y square plus 11y minus 6. Since this is a polynomial in y, so I will write py. Taking y is equal to 1, I want to know what will be the value of py. So p of 1 is equal to 1 cube will be 1, minus sign is there, so minus 6 into y square. So 6 into 1 square plus is there, so plus 11 into y, so y minus 6. You will get 1 minus 6 plus 11 minus 6. This comes out to be 0. So p of 1 is giving you 0. So again you can write 1 is 0 of polynomial px. Sorry, not this time px, this time py. Again there is a task for you. Check whether 2 and 3 are zeros of polynomial py or not. Thanks for watching.